Dear students, this video explains you how to find work done in moving a point charge in a given electric field along a given path. Let us go through the problem. See what is given here. We need work done. Given is a test charge 2 coulombs. This charge experiences force by the field. Electric field is also given 12x a cap x minus 4y a cap y. So field is given, charge is given. So you have to find the work done along the given path. Let us take up the part 1. Here the path is mentioned as from 200 meters to 000 meters. So the problem is in Cartesian coordinate system, as there are no angles given in the points. 200, this particular point lies along x-axis. So the charge is moved from 200 to 000. So in this direction. Right. So let us go for the work done formula. This is given by minus qt. Qt is the test charge line integral of electric field E. The limits are clearly given. The charge is moved from 200 to 000. The charge is moved from 200 to 000, the origin. So this is what is the formula we can start with. Now let us put the values given here. Charge 2 coulomb. The integration from the same point electric field we shall copy, that is 12x the unit vector minus 4y the unit vector dot dl, the differential length in Cartesian coordinate system is given by dx a cap x plus dy a cap y plus dz a cap z. We shall go from generalized formula for dl. Let us perform the dot product. The first term is having x component and dx is the x component, so dot product gives 12x dx. A cap x dot a cap y 0, a cap x dot a cap z is also 0. So corresponding components are multiplied in dot product. So we shall directly write the next step. So x components are multiplied together minus y components are multiplied together. So these two components are multiplied. And the z component, here z component is 0 because a cap z is not given. So 0 into dz is 0. So that doesn't exist. As usual, the limits are the points themselves. So here we have two terms which are to be integrated with respect to different variables. We can separate them. First one is 12x dx minus 2. After multiplication, we are having dy. Now let us give the limits for corresponding integrals. Here the integration is with respect to x. So we can have the limit of x component only. Since the variable in the first integral is x, we can take it as 2 to 0. Next, in the second integral, the integration is with respect to y, dy. So you have to take the coordinates of the y component in the given points, that is 0 to 0. 0 to 0. So that means the integration is carried out according to the variables and the corresponding limits will be considered. In the first integral, minus 2, 12 is constant. Integration of x is x square by 2. The limits are 2 to 0. Here it is minus 2. 4 is constant. Integration of y is y square by 2. 0 to 0. See the variable dy with respect to y. But the limits are 0 to 0 means along the y-axis, there is no change in y at all. So dy is actually 0. Since the limits are same, dy is 0. This integration can be avoided in the beginning itself if we can make out. So minus 24 upper limit 0, lower limit is 2, 8, and this is 0. If you continue here, minus 24, the first one is 0, 2 cancel, we are left with minus 2, second one is 0, so you are going to have 48 joules. So this is the work done or energy expended in moving the given charge 2 coulombs from the first point to the second point. So here, if you look into this diagram, so we got total work done of 48 joules. So in the second problem, we are moving from origin to 0 to 0. So that means this is given as y. A point is chosen here, that is 0 to 0, let us say. So in the part 2, the charge is moved from origin to 0 to 0. Let us see how much work is done for this particular path. So almost first few steps are same. So we shall start with the third step, the same thing. Dot product is common for all the steps. So 12x dx minus 4y dy we can start with. So here is some space. Case 2, work done is equal to minus 2 coulombs integral of 12x dx minus 4y dy. Only the limits change. Here we are going from the origin to a point on y-axis. As usual, we separate the integrals 12x dx minus 2 minus 4y dy. We shall give the limits accordingly. So here is dx. X is the variable, so we are going from limit to 0 to 0. As you know that along the x-axis, 0 to 0, no change. So dx will be 0. Change in x will be 0. The entire integration goes to 0. So if you go to the second one, let us say, it is with respect to y. So the y is changing from 0 to 2. So there is a change in y. So this integration exists. So here, just for the sake of mathematics, I'll do it. Otherwise, we know that it is 0. This is 0 to 0. Minus 2 minus 4 is constant. Integration of y is y square by 2. Limits are 0 to 2. So finally, the first term is 0. It's 8. 2 square by 2 minus 0 by 2. So finally, we are going to get 16 joules. So along the second path, we are getting the work done as 60 joules. So if you come down here, we found that 16 joules from 0, 0, 0 to 0, 2, 0. In the case 3, we have to move the charge from 2, 0, 0. That is here to 0, 2, 0. So in the case 3, the charge has to start from here and it has to so this is the path. If you read the problem, it says that from 2, 0, 0 to 0, 2, 0 along the straight line path, because from between these 2 points, there are several paths possible. Okay. So if you want from 2, 0, 0, we can go to origin and go to this point also. But he wants to know what is the work done in moving the charge from 2, 0, 0 to 0, 2, 0 along the straight line path. So for this case, case number 3, straight line path is given. So before that, the equation for W is already available. 12x dx minus 4y dy. So you are going from 2, 0, 0 to 0, 2, 0. So in this particular case, we should not separate the 2 terms and integrate, because if we separate the first term, then the limit will be from 2 to 0. Then it is change in dx, which will happen along x-axis. change in dy happens along y-axis. So we reach the point along this path. But actually the problem demands the path to be the straight line. So that's why now we have to obtain an equation which will define the straight line path between the 2 points. And we know that we can show that any 3 given points can be lying on a straight line. Let us say if this point is A and this fellow is B, then we have a relation for a straight line path. For a straight line path, from the mathematics, we have a relation to prove that given points are lying on the straight line path. Z minus ZB divided by ZA minus Z. Look at this here. I have chosen 3 points. One is an arbitrary point XYZ. Another one is the point A. Another one is the point B. Okay, this is the point A, the given problem. This one is point B. Okay, all the 3 points here will lie on a straight line if and only if this equation is satisfied. We have to verify that for the given 3 points whether the equation is satisfied or not. So according to our assumption, A is 2, 0, 0. B is 0, 2, 0. Then the first one will be XA, YA, ZA, and this will be XB, YB, and ZB. So you can use these coordinate values to verify to obtain the relation for straight line path. Then X, Y, Z are any arbitrary coordinates. So X minus XB. So where is XB? XB is this fellow, that is 0 divided by XA. Here is XA, that is 2. XB is 0 is equal to Y minus YB. YB is here, that is 2 divided by YA is 0 minus 2 is equal to Z. ZB, that is here 0, and ZA, the first point is also 0 minus 0. So we got an equation here. And if we solve this, and the first term will be x by 2, this is going to be y minus 2 by minus 2, this is z by 0. Now, to find useful thing, we shall consider any 2 terms from first 2 terms. Let us take first 2 terms. We'll see what happens. From the first 2 terms, we get a relation x by 2 is equal to y minus 2 divided by minus 2. Okay, here 2 and 2 cancels a denominator, otherwise we'll do it in the next step, no issue at all. So finally, what happened? 2 cancelled. Then x is equal to, you will get 2 minus y. This one is to cancel. So this is the relation between x and y to define a straight line path. So wherever x we get, we can replace it by 2 minus y. So that automatically a straight line path will be established. At that same time, we need to convert differential elements dx to dy also. So if you differentiate this, x becomes dx. Differentiation of 2 is 0. Differentiation of y is dy. So finally, dx is equal to minus dy. So from these two equations, we can completely replace x values and we can get only y values, so that x and y are automatically related, are placed on a given straight line path. So with these two, we can go to our equation of w. Yeah, you can continue from here. The work done is equal to minus 2 integral of 12x dx minus 4y dy. So if the path was not defined, I would have separated these two terms and integrated. Since the path is defined, so I have to build the relation between x and y as defined by this equation and this equation. So in the complete equation, I'm going to replace x by y. See, in place of x, I have put 2 minus y. And in place of dx, I have put minus dy. So x is converted to y. So that means, so x and y are related for the expected straight line. So y will remain same. So that means what I did, I converted all x to corresponding y so that both lie on the same straight line. Since the complete equation is in y, so the limits are required only for y. So we are moving the point from 2, 0, 0 to 0 to 0. So that means starting point is this fellow, y component is 0, ending point is this fellow, y component is 2. So the limits are 0 to 2 for y component. So minus 2, let us simplify for the mathematics. What happens here? We'll have 24, and here is minus for everything, and again here minus into minus plus 12y dy minus 4y dy. Since the variable of integration is the y itself, minus 2, so we can separate the integration, separate the integrals if we want. 0 to 2 minus 24 dy is one integral, plus 0 to 2 12y dy is the another one. 0 to 2 minus 4y dy. So we can make the integrals separate and keep it simple. So finally, minus 24 is constant. Integration of dy is y. 0 to 2. 12 is constant. Integration of y is y square by 2. 0 to 2. In this case, minus 4 is constant. and y becomes y square by 2. 0 to 2. So minus 2 is common for everything. So minus 24. Here 2 minus 0 becomes 2. 12. 2 square by 2 minus 0 by 2 minus 4. 2 square by 2 minus 0 by 2. We have the complete idea here. Minus 2. So what is left here? Minus 48. Next is 0. Here this term is 0, 2 plus 24 minus. Here also becomes 2 minus 8. So work out using calculator. You are going to get an answer of 64 joules. 64 joules. So we have completed all the 3 steps given, and all the 3 cases put together. We have a diagram here. As we know, in the case 1, 2002 000, we got 48 joules, and case 2 we have 16 joules, and the case 3 from point A to point B we got 64 joules. If you observe carefully here, so from point A to point B, so from point A to point B, there are 2 paths. Path number 1, 48 joules plus 16 joules, we got 64 joules. In the path number 2, we have a straight line path. The straight line path is different path, but still we got 64 joules. So that means in this electric field, moving the charge from initial point to final point through different paths, we are getting same work done. That is 48 plus 16 joules along one path, 64 joules along the second path. Both are equal. So the electric field is conservative. Electric field is conservative. That means the work done in moving a charge from one place to another place is independent of the path chosen. So irrespective of the path, the work done will be same in a conservative field. So that is the solution for this problem.